Hello, this is Shiki Chan demonstrating Assignment 3, the Maintain Toronto app. This assignment is on Spring Boot RESTful API services. I have created two projects. One is for the API service, and the other as the client calling the API services. This is the scripts to create a database and tables. Here we have three tables, the users, company, and the service request table. The service request table has the foreign keys, user ID and company ID referencing to the unique key in the user and company table. Now let's look into the API service part of the application. This is the application properties file for the API services. The REST service is running at port 8081, connecting to the database at port 3306. And here is the DDL auto. I have set it to none, so I'll create the tables with the table scripts just shown before. And this show SQL is to show the raw SQL generated by Hibernate. And this SQL basic binder is set to see the actual values binded to the query parameters for debugging. The service program contains only the service endpoints and the logics interacting with the database, so there is no views under the templates file. The three main entities of the app are user, company, and service requests. Each entity has its entity class, repository class, and the controller class defined. And since the application is providing some queries that joins fields from different entities, the service request DTOs is created to provide a structure to receive the results. Let's take a company as an example. The entity class is annotated with an entity and stating which table in the database it is referring. The table relation is defined here, specifying one company may have multiple service requests annotated with one-to-many. So on the other side of this relation, the service request here for the company ID is annotated with many to one. The repository files provide data access logic. The service request repository class declares some derived query method and GPQL queries to interact with the database. These are the queries for the admin reports that join service requests to user and company using the service request TDO for the output structure. The controller class handles an incoming HTTP request, delegates the data operations to repository methods, and returns the results to the client with JSON format. This is the REST API service part. Let's take a look on the client side. The client part will be running at port 8082, and instead of interacting with the database directly, the client part will call the endpoints defined in the service program and render the results to the wheels. So there is only entity class, controller class on the client side, and the wheels are defined here under the templates folder. The classes defined here are not true entity class. They provide a structure for data transfer. You can see there is a structure for the data login and the other structure for uh, rendering the report, analytic report results. The controller classes handle user interactions, manage UI behavior, and call the API services to fetch your data needed. So this is the user controller class. Here are some page transfer endpoint, and some are calling the endpoints on the API services. We call the endpoint using the REST template to send HTTP requests to the RESTful web services. This is one of the wheels, the user homepage. Timelapse is used to bind the wheels to backend data retrieved from the REST service. Bootstrap is applied for styles and responsive UI. This is all about the project setup. Now I will demonstrate the functionalities of the application. The application is accessible at localhost 8082. Here is the login page with the link to sign up, and click sign up. User can choose to sign up as customer or company. Without entering anything, you can see the validation done by entity class annotation. The same here for company registration. Let's try registering as a company first. I'm creating a company called Fairy Tale. The company can choose what services it provides. Let's say this company only offers lawn mowing. and the cost per square feet is 38 cents. So click sign up as company. Message shown after successful sign up. We'll try the company login later. Let's try customer sign up also. I didn't make the admin option here for the public. For simplicity, I will create an account and mark it as admin for administration page demonstration. So let's create a user here. After successful sign up, we can sign in as a customer. So as a new customer, there's nothing under the request history. You can choose to show only snow removal or lawn mowing companies only. Or with combined filters. Say I want to show companies with rating at least 3 and cost per square feet not more than 30 cents. Or you can simply stay only one or two of the filters. They are optional and you can choose the combination you want. If you want to book for a service, you can click the request service button. The company I have created just now provide a lawn mowing only. And let's try book for services from this company. Click the request service button. The request service page below customer name and select a company as read-only fields to ensure data accuracy, and service options are shown according to what is available to user. The date for service is set to allow future days only. And if the date is not entered, there is a alert message prompting here. Let's pick a date and click submit request. Once a request is made, it returns to the user homepage and the entry is shown under the request history. Now let's log in as the company. After login, company user can see list of open and closed requests. Just now, the new user has booked for the service in this new company, and you can see the service day and the status is now open. And if the service is done and the customer mark it as closed, now this is the user's view under the request history. And if you want to mark a request as closed, Just click the Mark as Closed button here, and the request status updated successfully. Then let's get back to the company's page and refresh it. You can see the case is closed. Now let's see admin login. After successful login, a list of reports are available. The first one is the list of company. The admin can assign rating here. Say the new company here doesn't have a rating. Now we are going to assign a rating to it. Let's say it gets a free rating here, and we click update rating. It is saved to the database, and a message showing the company rating updated successfully. The second one is company ratings aggregated by closed service requests. It shows the number of closed case and the rating of a company. The third one is request open for more than 30 days, showing the affected users, affected customer, including the customer details and the request created. You can see that requests shown here are created 30 days before. And the fourth one is company service cost per square aggregated by open service requests. This is for the snow removal only. And is aggregated by the number of open cases. These reports are retrieved by JPQL to join a service request with user info and company details. And this is the end of my demonstration. Thank you.